What is poppin', guys? It's Mr. Allen here with a video on inverses. We got ourselves a couple cubic functions to deal with in this one. We're going to find the inverse, graph, and list out some characteristics of each. So let's get it going. I got to swap my x's and y's. First thing I like to do, though, is I do like to write it as y equals x cubed minus 4. Then I'll swap my x's and y's just to stay nice and organized, right? Sometimes there's like multiple x's you got to deal with in weird spots, so I like to write it out y equals first, okay? Now I got to resolve this thing for y. So I'm going to add 4 to each side. I'll get x plus 4 equals y cubed, and then I will go ahead and cube root on both sides. And I'm going to swap how this is written now. We're going to have y equals the cube root of x plus 4. Okay, so there we go. So my inverse here, f inverse of x equals the cube root of x plus 4. Nice. Excellent. First thing done. Check it off the box. All right. Now we got to graph some things. So let's graph the first one here. I'll graph this one in blue. All right. So we got x cubed minus 4. And I think it can be helpful to have a t-chart. You kind of do some of this stuff in your head. If you know what the parent function looks like, we can just shift it down. But why don't we go with a couple t-charts, shall we? And I think we'll have enough room right up in here with these graphs. All right. So if I start with a t-chart for this one, we'll get a few points going. We've got x, and we have f of x. Okay. Since there's no transformation in the function there, I can start with 0 being like my center point there. So I'll put that in the middle here. Then we'll do like -1, -2. We'll do 1 and 2. We'll get all those points, okay? So if I plug in 0, I get -4 here. If I plugged in -1, -1 cubed is -1. -4 is -5. If I plug in -2, I get -8 when I cube that. -4 is -12. So that's going to go off my graph. We won't graph that one. If I plug in 1, 1 cubed is 1, -4 is -3. And if I plug in 2, I get 8, -4 is 4. All right, let's plot these points here. So we've got -2, -12 is way down here. We won't graph that one. -1, -5. 1, 2, 3, 4, 5. Then I got 0, -4. We got 1, -3. And then we got 2, +4. Okay, so this is just my, parent cubic function that has been shifted down, right? It just shifted from the origin on down. All right, now let's get our inverse. And because we did the t-chart here, it actually makes our life pretty darn easy because we could just swap our x's and y's. And then, I'm going to do that. -1, there we go, of x. I'm going to do that in this one. Saves a little bit of time. And we're also going to see how when you plug them in, it does work itself out, okay? So I'll have -12, -5, -4, -3, and 4. And then, right, we got that all right. Cool. I like to go straight down when I do this. I don't like to do the ordered pairs because then I mix things up. Then we got -2, -1, 0, 1, and 2. All right, so if I plugged in 4 here, we get 4 plus 4 is 8. The cube root of that is 2. If I plug in -3, -3 plus 4 is 1. Cube root of that is 1. If I plug in -4, I get 0. Cube root of that is 0. So on and so forth. So it will check out. I already have the t-chart. Why not just write them down? Makes it easier to plot, and I don't screw anything up. Cool? But it is good to maybe double check it, make that connection there, okay? So let's plot them. Can't do the first one. It's going to be way over here. I mean, I could do it, but we won't. -5, 1, 2, 3, 4, 5. Down 1. -4. 1, 2, 3, 4, comma 0. -3, comma 1. And then 4, 1, 2, 3, 4, comma 2. So we know it's going to be coming in like this. Boom. All right. And once again, for those of you that have been watching some of these videos, I like to graph in yellow here my y equals x line, which will pass through where those two intersect. And it looks like it does reflect across it. The blue onto the pink there kind of spins around it. It's like DNA or something like that. Anywho, there we go. We got our graph of our original and our inverse. of that f of x function. Awesome. Let's get some domain and range going and whatnots. The first one, we'll do that in, blue for my original function. The domain of that one. Well, I never stop going to the left, never stop going to the right. Basically, there's no numbers I can't plug in. Therefore, x is all real numbers, or negative infinity to positive infinity. However you want to write it, however your teacher wants you to write it, I'd follow that. So if your teacher's an interval notation kind of person, it would be this. Okay? You do not need to write both. That's the equivalent of this for interval notation. Cool? Range down. Well, it never stops going down, never stops going up, so range is y equals all reals, or the negative infinity to positive infinity. What's my x-intercept? That one's a little trickier to find, right? It's between, looks like between 1 and negative 1. Well, let's figure it out, right? We can figure it out. I could set my equation, my function, equal to 0. I could do 0 equals x cubed minus 4. So if I add 4, and I have x cubed, I'll take the cube root. So now I have the cube root of 4. So I had it cube root 4, comma, 0. That works, right? Cube root of 4, well, the cube root of 1 is 1. The cube root of 8 is 2. So 4 has got to be between 1 and 2, and it clearly is, right? So that makes sense. If you had a calculator, you could plug it in, get the decimal equivalent, whatever it is, 1 point something. But there we go. And then y-intercept. Where's it crossing the y-axis? 1, 2, 3, 4. So that would be 0, comma, negative 4. Okay. Now, for our inverse. The inverse here, the domain never stops going left or right. Range never stops going up or down. It's going to be the same here because, right, they do switch, but they're the same, so it's going to stay the same. X equals all reals. Y equals all reals. My x-intercept here is negative 4, comma, 0. And my y-intercept is, it looks like somewhere between 1 and 2, right? This is going to be my 0, 0, comma, and it'll be cube root of 4. Which we could solve if you set this equal to 0. You'd cube, if you plugged in 0 for x, 0 plus 4 is 0, cube root of 4. That works out. Cool. All right. Wonderful. Fantastic. That's beautiful. That's just it's dope. All right. Cool. I don't know. There's nothing else to do here. I don't know why I'm still just staring at it, but it just looks great. Okay, let's move on. Okay. For this one here. You know what? Actually, one other thing. You just notice how we don't have any domain restrictions like we have with the quadratic? It's because the inverse is going to end up being a function when it's a cubic like this, right? Some cubics are going to be a little crazier and the inverse won't be a function, but these will be a function, so we didn't have to restrict the domain to make sure that the inverse was a function. The inverse stayed a function, right? This pink guy passes the vertical line test just like the blue one there. The blue one passes the horizontal line test. Therefore, it is invertible, or its inverse will be a function. All right, now we're good, okay? Now we're good. Let's find the inverse of this one here. So we'll start out the same way. I've got y equals, and then we have x plus 2 cubed. X equals, swap my x's and y's here. And then I got a cube root. So we get, let's see here, cube root of x equals y plus 2. And then I'm going to subtract 2, but I'm going to rewrite this thing as y equals the cube root of x minus 2. And a lot of times we'll throw a little negative 1 right here because we are dealing with the inverse at this point. But because I'm also writing it in function notation properly here, I'll put the negative 1 up there. Almost forgot it. And then we got the cube root of x, and that minus 2 is on the outside now. So one thing we might notice here is that the negative 4 here, well, the minus 4 was outside of the cubed part, but then it ends up in the cube root. Here, the plus 2 was on the inside, but now a minus 2 ends up on the outside. Those patterns will occur. I wouldn't rely on remembering those or memorizing those things to be like, oh, I just don't have to do any of this work. I can eyeball the inverse. You'll screw something up. And a lot of times we want to see the work. You get points for the work, so make sure you are swapping your x's and y's and showing all those wonderful steps. All right. Now, let's get to work. We'll do a t-chart again, I think. It's a wise idea. So I'll get the blue one going here. X, g of x. So let's see here. I'm thinking I want to make this part right here 0. That'll be where I center this graph around, right? That's where that inflection happens there. So I'll put negative 2 here. That'll make it 0. And then we can go to negative 3 and negative 4. Here we'll go to negative 1 and 0. So let's plug those things in. If I plugged in negative 2, we said we get 0, which is cubed, is 0. If I plug in -3, I get -1 cubed is -1. If I plug in -4, I get -2 cubed is -8. If I plug in -1, I get 1 cubed is 1. If I plug in 0, I get 2 cubed is 8. Nice. Excellent. Wonderful. All right. Let's I'll plot them. Let's plot them. So we got -4. That way, in case there's any kind of like, I don't put it in the wrong spot, and then my T-chart's in the way for the inverse. So we got -4, 1, 2, 3, 4, -8, all the way down. I think I made this one 8 long, right? 1, 2, 3, 4, 5, 6, 7, 8. Whoop, good. Okay, and then -3, 1, 2, 3, -1, -2, 0, -1, 1, and then 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Who do you appreciate? Math. Okay. Connect. Boom. Yeah, I kind of missed that one. Oh, well. Darn it. There we go. Just kind of bold it. All right. Let's get our inverse now, shall we? I'll put a pink T-chart here, and we can just go ahead and swap our X's and Y's. And we'll do a little check like we've been doing here to make sure that it all does check out. So -8, -1, 0, 1, and 8. -4, -3, -2, -1, and 0. Man, that's fast. When you got a T-chart there, and I can just swap my X's and Y's. If I plugged in -8, cube root of that is -2, minus 2 is -4. If I plugged in 8, cube root of that is 2, minus 2 is 0. If I plugged in 0, that's 0, minus 2 is -2. Look at that. They all check out. I don't even have to do all. I did 3 out of the 5. That's enough. That's a 60%. I'm passing, right? Okay. Let's keep it rolling. -8, 1, 2, 3, 4, 5, 6, 7, 8. -4. -1, -3. We get 0, -2. 1, -1. And then 8, 0. So now we'll connect these dots. Boom. All right. Kind of bent right there a little bit. Oops. But once again, as I've been saying, draw that y = x line right through that origin there. It will, for these, hit at that point right there where they intersect, right? And you can see, once again, the blue kind of like, right? Twists, kind of like these ones did here. It's awesome, man. All right. Let's get some features here, and then be done with this thing. So domain, all real numbers. Range, all real numbers for both. Right? It never stops going left or right, never stops going up or down, so it's all real numbers. X-intercept. Looks like I got myself -2, right? So -2, 0. My y-intercept, 0, 8. Nice. We didn't have to do anything with that one. That's cool. Nice integers on this one. We didn't have to do any kind of solving or anything weird. It just worked out. Okay. Next one here, we know we got all real numbers this way, so that's my domain. All real numbers up and down, that's my range. My x-intercept. Where's it crossing the x-intercept? All the way over at +8. Where's it crossing the y-axis? At -2. So we've got ourselves 8, 0 and 0, -2. There we go. Man, you guys can be pros at getting some inverses, graphing them, give me all the dope features and stuff like that. Tell me if they're a function, passing that vertical line test, both of them, everything's a function here. It's one of my favorite F words. Factor is my favorite F word. And then it's fraction, and then it's function, okay? So, there we go, man. Inverses. Hope you guys liked it. Make sure you like it on the YouTube, right? That helps people see this video. And then have a great day, you guys, and keep on math and keep on watching the videos, and stay awesome.